I'm one of our product managers at Eaton. I work for our panelboard and switchboard product line based out of the Carolina region, which is where one of our main plants is in Sumter, South Carolina. Today I just wanted to talk about some new and exciting stuff we got going on with our panelboard and switchboard product line.
Awesome. Thank you. And I had myself on mute in the beginning, but I caught you right when you started.
Okay.
Nick Cluse, how about you?
Yeah, good morning or good afternoon, everybody. My name is Nick Cluse. I'm product line manager for safety switches and dry type transformers here at Eaton. Today be representing really more so the safety switch product line, but I'm representing the 300 or so people here at our Cleveland, Tennessee manufacturing facility. So glad to be with you guys.
Awesome. All right, so first up we have Manny Alexander. Let me get you up there. I think you are going to be 2 PowerPoint wide. There you go, Manny. Take it away.
Cool, thanks, Tom. Well, like I said, it's a pretty cool and exciting time to be part of the panelboard and switchboard product line at Eaton. We got a lot of exciting stuff going on. I mean, when you think about the last few decades, just in general, with technology and how much it's evolved, there's been a lot that has changed, right? You think about how cell phone technology has changed, how IoT has changed, and it's a great opportunity for us now to start to leverage a lot of the new technologies that are available to basically embed those into the foundational component of electrical distribution, which is circuit breakers, right? And we use circuit breakers throughout our panelboard and switchboard assemblies. So wanted to introduce to you our new line of intelligent lineup of panelboards and switchboards. The Pow-R-Line Xpert family, like you see on the screen here. A lot of great stuff. We like to talk about all of these key features that you see on the screen, that it's predictive with breaker health diagnostics, and we'll unpack that a little bit here in a couple slides. We have integrated metering capabilities to make it insightful. You think about all of those widgets that you have to install in assemblies or maybe external to the assembly in order to meter branch circuits. A lot of connection points, a lot of different devices that are connected together, but now we have built-in metering into the trip units that removes all of that clutter and extra devices that are needed to meter at a branch level. We have standardized ARMS functionality, ARMS being the Arcflash Reduction Maintenance Switch, which we'll also talk about here today. Through cover accessories. This is a great one because in the field, if you have to install maybe a shunt trip or a UVR in the breaker, there's a secondary removable faceplate that is very easy to take off and kind of plug and play or drop in those accessories to plug and play with whatever the device is. Gives you that flexibility to make those changes in the field without voiding any factory warranties. We have embedded Modbus communications, which is another thing I'll touch on today. All of the data that these breakers are collecting is incredible and great, but we want to be able to provide that data to a higher level system for, action to be taken. Other things such as the ability to plug your computer into these micro USB port or via micro USB port into the trip unit gives you the ability to perform secondary injection testing on the breaker, pull all of that great breaker data, perform test reports that can be compiled in PDF format. So just a lot of great things that you can pull from these breakers used in our panelboards and switchboards. And last on the screen are the re-engineered dead front covers. So, if you think about some of the dead front covers that are in the field today, the opening is only wide enough for that breaker handle to fit through. So, if you needed access to basically confirm what that breaker is, maybe it's a spare in the field, you needed to maybe do a study down the road, you often want to verify the faceplate information on that breaker. So we've re-engineered the dead front covers to basically have a wider opening to give you that complete visibility to the breaker faceplate information. And now with the electronic trip units that have keypads and LCD screens, obviously it's easy access to those as well. Next slide, please, Tom. Yeah, so I said I was going to unpack that standardized ARMS functionality or the Arcflash Reduction Maintenance System. And sometimes that's a little ambiguous when I say that. So just to be clear, I'm not saying that ARMS is on every single circuit breaker that we that we sell in our assemblies. What I'm saying is now we have a standard, new, consistent user interface for that Arcflash Reduction Maintenance System across all of our breaker offerings. So, Power Defense offers really multiple methods of arc flash mitigation, but for applications where that maintenance is performed locally at the breaker, that Eaton Arc Flash Reduction Maintenance Switch, or again ARMS, is a really great solution. If you think about an electronic trip unit's instantaneous trip setting, it's capable of clearing a fault within roughly 50 milliseconds or so. But that arc flash reduction maintenance switch uses a separate analog circuit, so that bypasses the electronic trip unit's microprocessor that requires time to boot up, perform current conversions, and execute its code. So by cutting out the need for computing time, the analog circuit can provide even faster breaker clearing time in the range of 10 to 30 milliseconds instead of that 50 milliseconds that I mentioned before, which results in a much lower arc energy exposure to the maintenance staff. In some cases, using ARMS can actually reduce the NFPA 70E hazard risk category classification. So, potentially requiring less PPE to work on an assembly with breakers. And when ARMS is engaged on the breaker is put into maintenance mode. So maintenance mode can be turned on via a local switch at the trip unit, like you see on the screen. It could be done remote switching via 24-volt DC powered contact or through the built-in communications. So you can confirm that maintenance mode is on by the solid blue light on the front of the trip unit, by using a relay contact connected to a remote light or other signal, or by reading the status via the communications as well. Next slide, please. So I think Tom would agree that this is a really cool feature. It's one of my favorites. A long-standing question in the circuit protection industry has been, when is the end of life for a multi-case circuit breaker? And in reality, it depends on how the circuit breaker is used. Is it operated frequently? What kind of fault events has that breaker seen? What are the environmental conditions of the breaker? Ideally, there would be a way to monitor these variables to predict how long the breaker will operate successfully before it approaches an issue or end of life. So with the advanced features of the power defense breakers and the PXR electronic trip units, Eaton has introduced this powerful diagnostic capability into our molded case breakers and insulated case breakers. So the PXR is smart enough to monitor variables such as how many faults has the breaker seen and how high were those faults. Has the breaker encountered an overload condition? How many times has the breaker been physically operated? Is it used as an on-off switch or left alone in the field? Maybe how long has the breaker been in service in terms of days and hours and even minutes? What's the internal temperature of that breaker? Is it somewhere hot and humid, or is it somewhere where it gets cold? So, these PXR trip units incorporate all of these metrics into a proprietary algorithm that we call breaker health. And it gives that real-time health percentage of the breaker. If the breaker sees standard use, the breaker health will go down slowly over time. If the breaker sees significant fault hits or maybe excessive physical operation, the breaker health will degrade faster. So that raw data is collected by the trip unit. It can be viewed as individual metrics or aggregated into that total health measurement up to 100%. With this information, scheduled maintenance can be performed based on the system health, or a breaker that is nearing end of life can be replaced to avoid that unplanned downtime. So when I talk about this feature all the time, I say it's kind of analogous to my cell phone or your cell phone, right? If you look in the top right of your iPhone or Android, whatever you have, you want to check your battery life. And I'm looking at mine and it's at 41% right now. So I can make that judgment call. Is 41% enough for me to get through the day? Or do I need to take action, whether that's plugging in my phone, or maybe it's, hey, I had my phone plugged in overnight. It shouldn't be at 41% now. I need to investigate what's going on with my charger. Maybe I need to replace my charger. So that's a very simplistic way and a very simple analogy to breaker health, but it essentially does the same thing, right? It gives you the ability to monitor the health of your overcurrent protective devices within your panel board or switchboard assembly to avoid that unplanned downtime, or maybe you want to get a replacement breaker on the shelf so that when something does happen to that breaker, if it takes that hit, that next fault that maybe puts the breaker at end of life, you're prepared to quickly get your operations back up and running. Next slide. So I mentioned the built-in communications on a couple slides, and these power defense breakers with the PXR Power Expert release trip units have built-in Modbus communications because all of these trip units are collecting an immense amount of data. And like I said earlier, you want to be able to communicate that to something in order to create action, right? And to use that data. So often, what we'll do from our factories is factory daisy chain those breakers together with the Modbus communications up to something, whether that's maybe a Power Expert gateway where you can connect to a PLC, an operator interface like Galileo, or maybe instead of a gateway, you might use maybe the Power Expert dashboard light processor, which is really cool because it basically compiles all of that great data that the PXR trip units are collecting and presents it in a very intuitive dashboard that gives you the ability to not only look and pull at the data with that interface, but also click on the devices and maybe load set points remotely or activate arms remotely when you're outside of that Arcflash boundary. So a lot of great things you could do with that communications, a lot of great ways that you could pull all of that great data up to whatever the system is that you have on site. And I'll just tell you that, with our 19 plants that we have across the country and all of our great, time-tested solutions, there's endless possibilities for how these can be configured. So, no job is really created equal. There's a lot of different applications. There's a lot of different needs from different customers. And with all of our plants and all of our solutions, we're really positioned well to come up with the best solution for our customers. Next slide, please. So, that's really what I wanted to touch on for the new Pow-R-Line Xpert panelboards and switchboards. There's a lot of other great stuff that the new line brings to all of our customers in the field. But if you want to learn more about that, I encourage you to visit our sites, eaton.com/Guardian of the Grid. The Guardian is our fictional character that kind of personifies all of these great new features of the Pow-R-Line Xpert panelboards and switchboards. But if you have more component-focused questions about the breakers themselves or the trip units themselves, you could also visit eaton.com/power defense to learn more about those breakers, because there is a ton more capabilities. We have white papers available, marketing literature available. So enjoy checking those out, and we look forward to helping you out on your future projects. And thanks for your time.
Awesome.
Any questions, Tom?
Awesome, Manny. You do have a couple questions before we go over to Nick. Brian Holland was asking, can the product line also provide, can these breakers that you're talking about, and you might want to speak to how low you go, but ground fault protection of equipment and arc energy reduction. So can the new product lines offer both of those technologies? Is it both in the same? And then can you speak to how low you can get those solutions to?
Yeah, the smallest frame breaker that we use in the Power Defense molded case offering is the Power Defense frame size 2. And that frame size 2 is basically a 225 amp molded case breaker. So you could get ground fault protection with that 225 amp breaker. You could get arms functionality across the board on all of the molded case breakers from the PD2 up through our 1600 amp Power Defense frame 6. And you could get those in the same trip unit. So you might have like an LSIG trip unit with arms functionality. The ground fault functionality is great with the PXR trip units because you actually have the ability to turn on and off the ground fault as well. So, if you're testing your system, or if you have some nuisance tripping or some ground fault issue that you're trying to basically diagnose and investigate, you have that ability on the trip unit to turn on and off the ground fault functionality.
Awesome. We got one more from Paul. Now, Paul Oslin is very interested in 240.67, so that's coming up. But he had another good question I thought was really interesting. He says, if your arms energy reduction could be damaged during primary injection testing. Because remember, 240.87 now requires testing. So how do we handle testing the arc reduction maintenance switch technology? Do you know?
That's a great question. I would probably have to pass that off to our engineers to get a little more technical on that response.
I can help you with that one.
Okay, cool.
So there's a few ways to handle 240.87. from a testing of the arc reduction maintenance switch, there is a feature that you can use with the breaker that you can put into test mode and test that. That would be like almost like secondary current injection testing. But if you think about the requirements of 240-87 and 240-67 is 1200 amps and above. GFPE is required 1000 amps and above, and you're required as part of 230-95 to test ground fault protection of equipment via primary current injection testing. Now, what I've been telling everybody, do both of these testings at the same time. If you're testing GFPE at 1000 amps and above and you're doing primary current injection testing, you can test that arc reduction maintenance switch because it has a very low setting. You have two and a half times or 2 times the rating of that device. So if you have a 1200 amp, all you need is 2400 amps to trip that device, and more often than not, you're going to have the equipment to do that. But we do have methods to do that testing separately as well. So just be mindful of that. Cool. All right, Manny, anything else, brother?
That's it. No,
Okay.
Thanks for your help fielding the questions. That's why they pay you the big bucks.
Yeah, I wish, checks in the mail, right? All right. So you know who we have up next is we have our brother, we have our buddy Nick Kloos. And Nick, I'm going to queue up your PowerPoint, so give me a second here.
Sure.
And we're going to get him off, and you just have the 3 slides, so that's a good thing. Short, sweet, to the point, and then we're going to answer Paul's question, I believe, as you go on. So you've got the floor, my friend.
Okay.
Take it away.
Well, thanks, Tom. Like I said before, my name is Nick Kloos. I am the product line manager here at Eaton for both our safety switch and our dry type transformer product line. Today's discussion, again, wrapped around safety switches. And really just wanted to say thanks for the opportunity to come to talk to you all about some of the exciting things that we've got, one of the new products we've got relative to our safety switch product line. Like I said, based out of Cleveland, Tennessee, which is just a little bit northeast of Chattanooga, where we manufacture all of our safety switches, and we also have all of our supporting functions like design engineering, marketing, and things like that. And really, if you look at the Eaton safety switch portfolio, one of the things we've really made strides in doing is not just resting on one core product of general duty or heavy duty safety switches. We try to obviously provide those because that's a tried and true product for really in the industry over 100 years in a lot of applications. But we really do feel like there are certain applications, there's certain scenarios where we can provide value added features that can give additional functionality, or really our favorite is instances where we can provide additional protection for workers. So again, probably not time today to talk about all of these different things that we've worked on to diversify our product line, but I would encourage you to go to eaton.com/switches, and you can really see a lot of different products that we've developed through the years. That either, again, give you that enhanced functionality for specific applications, or we do have a nice line we've had safety switches. We call them safer switches, where we've designed some features into them. But today, if you want to go to the next slide, Tom, I know one thing, especially for this audience that's of particular interest, is 240-67, which as was mentioned earlier, really applies to having some sort of plan or some sort of product to integrate arc energy reduction on 1200 amp and above fusible devices. So obviously 240-67 has been around. I'm sorry, 240-87 has been around for a while relative to circuit breakers. And Eaton's approach there has largely been our ARMS feature that Manny was talking about. And when the code drove us to 240-67, really that presented an interesting situation for us in the safety switch in the fusible world, because really was again something from a circuit breaker standpoint we'd addressed through, as Manny said, the trip unit or the bypassing of the trip unit through some technology to make it act quicker. But when you think about a safety switch, which really was frankly a mechanical device that integrated overcurrent protection by fusing, it presented some unique challenges of how to address this code this code requirement. So the first thing we had to do was find a way to remotely open a safety switch. Circuit breakers have had shunt trips for years, but if you think about a safety switch product, really the only way to open that product historically had been to walk up to the handle and turn the switch off. So our engineering team really as a first kind of piece of the pie went to the drawing board and developed, you can see kind of in the gutter there between the handle and the mechanism, a shunt trip mechanism to remotely operate a safety switch. One of the things we're proud of, we do have that. You can see to the right from anything from a 400 to 1200 amp design, and we sell that as a standalone shunt trip safety switch design. So even if you have an application where it's not necessarily needed to have arc energy reduction or ground fault, you can buy a remotely trippable safety switch from us. But relative to the discussion today around 24067, the second piece of the puzzle was for our engineering team to go and develop some technology that could tell the switch to open, much like our arms feature in our circuit breakers. So we went into development, and now we currently have a relay that you can see there kind of blown up there on your screen, a relay that acts very similar to the arm switch on a circuit breaker, given that it's got a maintenance mode that can significantly reduce the arc energy reduction. But what we had to do in our case was really design a product that could do that, but also do it in conjunction with the fusing that's present in the switch to make sure that depending on what type of event was taking place, the switch acted appropriately. Did the relay address the situation, or did the relay stand back and essentially let the fuses take care of the problem? So I'm going to get to a minute where you can find more about that because it probably goes beyond the intent of today's discussion. But that's some of the stuff that went into developing that. So again, when you think about a standard safety switch now to a safety switch with a shunt trip mechanism and then also this relay built in, the other key thing to point out is if you look at the picture of the safety switch, this is really a fully assembled product designed to tackle 24067. So you not only get the relay and the shunt trip, but you also get the required current sensors and all the wiring is factory done to connect to that relay, meeting all UL 98 code or UL 98 standards and factory tested here at the plant to ensure that it's operating correctly. So it's really an out of the box solution for this product. One of the things too that I do point out to people is 1200 amps and above, it does address a code need, but that doesn't mean it's not a good idea to potentially apply elsewhere on lower current circuits. So again, we can put this in our 400 through 1200 amp designs, and then you think at 400 you can fuse it down even lower from an ampacity standpoint from that. So really you've got a pretty full spectrum in terms of where this can be applied. And one last point around that trip unit is aside from the arc energy aspect of it, one place that safety switches potentially could have been used historically was on 480 volt service entrance circuits where ground fault's required. But again, historically, ground fault wasn't available on a safety switch. With this relay, you do now have ground fault. So if you're looking for a fusible service entrance device at 1200 amps or 1000 amps and above, this product will meet your need there as well from a ground fault protection standpoint. The next slide, Tom. And my last slide, really just again, the intent of today's discussion was just to let you guys know about the product, number one, because like I said, it is a very it's a fairly significant advancement in the safety switch product offering that's available in the market today. And so number one, wanted to make you aware that it's an option if you've got jobs that require this, but also didn't want, if you're doing an inspection or something like that, where if you saw this, it was kind of, hey, what is this? And it was the first time you saw it was on a job site. So wanted to drive awareness of what this thing was. Again, there's a lot of technology that went into this. There was a lot of thought to how that relay would work again in a fusible context. So the document on the right, if you go to eaton.com/shunttrip, we've got it's a fairly lengthy document, but it has a lot of the different curves and different settings and things like that. And it's got this various schematics and things, related to how that trip unit would function, or how that relay would function. So again, past what we want to discuss today, but I do want you to know that is available. I'd encourage you to reach out to that website and go through that. And I think it really explains very well what that product does. And if you also have a need where you just are trying to, again, raise awareness of what 24067 is, show that there are products available, we've got some more concise, more, we'll call them marketing type documents as opposed to engineering type documents, which is what you see on the right there. So again, cool product, really excited, really proud of our engineering team for, taking a pretty seismic, requirement relative to code and running with it, developing the product and creating something that hopefully keeps people safer out in the marketplace. Because ultimately, if we can do that, that's a pretty big win for all of us. So
awesome. Well, Nick, we got a couple questions for you. Bill Shell is asking, are all of your safety switches, do they have the required PPE level applied on the outside of the cabinets? We'll take that one first. So PPE level, remember, Bill, PPE is determined based upon available fault current, arcing currents, and a systems analysis study. Nick is a smart dude, and he's got a lot of other smart dudes working with him. But we can't label that equipment before it leaves the factory with a personal protective equipment level layer, because you're required to rely upon, based on IEEE 1584, the upstream overcurrent device that's feeding that equipment. We don't know what that is, and we don't know what the fault currents are. So we can't put the PPE level on the outside. So I think that, I don't know, Nick, if there's, makes sense. Anything to add on that one?
Yeah, I mean, I think you're right there in that different installations have different different things that go into that, and a study really in each case can kind of tell you what those PPE levels are. What I will say though is whether it's this device or whether it's the ARMS circuit breaker, which by the way we do have a standalone enclosed version of that breaker that Manny was talking about. If you don't need an entire switchboard. We have seen instances where people have done those studies and they say, hey, my calculations are showing where I need to find some way of having arc energy reduction at, let's say, this main leg only motor control center, something like that.
Yep.
These are two really good products where you could I don't want to sound like I'm a contractor that's done this work before, but reasonably easily put this maybe in front of, say, a main leg only MCC or some piece of equipment where, again, you need some energy reduction to bring the PPE more in line with where you'd like it to be than maybe where your current system is at.
Yeah, that's a good point, Nick. And also, we know that if you have available fault current, you can calculate a minimum arcing current. And with these products, you can significantly, whether it be a breaker or a fusible switch that's using this relay, if your fault currents are above a certain value, you can estimate or calculate what the maximum calories would be to determine a PPE level, and say anything downstream at that next level to equipment, as long as the fault current is above a certain number and you have the arm switch on, then you can dress a certain way. So, and that's the creativity that engineers and others can employ. Another question for you from a switch perspective. Also, can you open the switch without turning it off and service it energized?
Can you open the switch without turning it off? And so, yes, part of UL 98 does require that as safety switch manufacturers, we have a defeat mechanism that would allow you to do that. So our heavy duty switches as standard, when you turn a switch off, when you turn a switch on and the handle goes to the up position, there is an interlock there that latches your door shut, because obviously 99% of the time that you're on that, you're around that switch with it on, you want that door to be closed and nobody be able to gain access to it. But again, the UL standard does say that, hey, there are instances where somebody would need to do this. So you need to provide a provision to defeat that interlock and be able to get into that switch with it in the on position. So yeah, you can technically do that.
Awesome. And I got a question in from Paul as well, and I'm not sure if it is. I'm not sure if this is to you, Nick, or if it's to you, Manny. And Paul hopefully will clarify that. But he's asking, can your trip unit be used for coordination? Oh, the switch relay. So Nick, can you elaborate on? I'm not sure how familiar you are with the coordination aspect from a trip unit perspective, but how would you apply that from a coordination select, like say you're doing a coordination study. That relay has a trip curve, right, associated with it.
Yeah, correct. It does, and again, a lot of that is captured, in that technical data that we've got. But yeah. And if you go back to and if you looked at the picture of that, I mean, the relay, you can see there it does have some adjustability on it in terms of they're down at the bottom. So
Yep.
So if you have a study and you need it to perform a certain way, it is an adjustable device. And again, you can, based on what your study says, adjust it as necessary to make sure it operates the way that you need it to.
A good point. And if since it's a ground fault protection, we have to coordinate ground fault protection, and there's a trip curve associated with that, and the adjustments on that will let you move that curve around within the requirements of obviously of the NEC 1000 amps and above. You can only go up to 1200 amps and 2-second delay, etc. But like you say, that's very adjustable, and you can apply the arc just like the breaker guys. Let me get Manny back on here. Manny, how low can I apply an arc reduction maintenance switch on the breaker frame ratings? Or you're muted, buddy.
Sorry about that. A 225 amp frame breaker.
225 amp frame, which can also be adjusted down even lower than 225 amps.
Absolutely. Yeah, I
So
can go down, I think, to 60 or 70 amps.
Excellent. Nick, how about you, buddy? How low can you go?
Well, again, so on our safety switches, we have this designed through our 400 amp safety switch. So really, at that point, from a 400 amp switch, really any fuse that you can put in there, that's 400 amp and below, you can, really go as far down from there as you want.
Awesome. And plus, I mean, if you're buying fuses, your fault currents are so high, you're probably the arcing currents are high enough anyway. You're not buying a fuse because you've got 2,000 amps available fault current. You're buying a fuse because it's up there. So,
yep.
Cool beans. Any last words, Manny and Nick?
No, thanks for having us.
Awesome.
Yeah, no, I'd just say thanks. Always appreciate the forum to talk about this, and again, I think it really shows as product line and as a company how we're trying to address obviously the codes that are required, but also we do take seriously trying to create safer products for our customers. If there's feedback around what we have designed, and again, I'd say I'd encourage all of you to check out eaton.com/switches. For some of our other value-added safety products, and like I said, I think that's really where, as an industry, hopefully we're going, because if we all pay attention to, the safety that's required, if we have codes driving to safer working conditions, and as manufacturers we partner to develop products that do that, I just think it really contributes to a much better industry, and one where everybody gets home safe at night. So happy to be part of that. But if there's ever suggestions or ideas, we are happy as a product line to hear those and try to address them and take them on head on. So, but thanks for everybody's interest today. Awesome.
Thanks, guys. And thanks to everybody out there in YouTube land and all the all our viewers in the Eastern Section. And we are going to, this is our last vendor. So for today, you guys can go and take a break, get something to eat, and come back for the 2 o'clock session, which I'll open the channel around 1:30, so I believe. So, all right, everybody. And we're going to fly out over the city and say goodbye. Take care. Stay safe, and we'll see you guys, everybody, at 2 o'clock today. All right. Thank you.